So this tutorial is to show the use of the Rugby Blockchain smart contract that simulates the creation of a player card as the ERC721 token or a NFT. So this card will have some properties such like the position, the last name, the first name, the scarcity, season, strength, and etc. And the card, so two users could exchange the cards, but also a user can open a booster in order to get a card. So getting the card could be realized through these two processes. So let's start. So as you can see here, this is the smart contract. This one. This is the smart contract that I created, and I imported the OpenZipLink library, the ERC721 OpenZipLink library, in order to create NFTs or ERC721 tokens. So I import them here through the inheritance. So next, I created some structures that represent a user and a card. So these two entities are the same, but I prefer to separate them because we also need some security to access the wallet. So for security purposes, I created this user structure. So here is the card structure. It contains some properties like the card ID, the card owner, which is the owner of the card. So the user which owns the card, the club, the position, the last name, the first name, the scarcity, the season, the strength, the endurance, speed, and level. So next, we need to define a deposit address here. So I created some mapping, like the cards mapping, which map the card ID, as you can see here. Sorry, as you can see here. So this is the card variables, which is a mapping between a string. Sorry. Okay. So this is the card variables, which is a mapping between a string. In our case, this string is the card ID and the card structure. This card structure here. And also we define a user mapping which maps the user address to the user structure. And we also define a card owners mapping which maps a string to the address, where this string here is the card ID, and the address here is the address of the user which owns that card. So here we define some a unit counter which will increase every time we create a NFT card or a ERC721 token. So in the constructor, we need to specify the deposit address. So this deposit address is the address where all Ether will be sent. For example, when a user opens a booster in order to get a card, it needs to pay 0.05 Ether. You can see it here. For example, in the open booster, let's see the open booster function. This is the mint function, and here. So as you can see in the open booster here, we transfer Ether at the end here. So we can see that in this function we transfer, so deposit.call, we transfer some Ether to the deposit address, because when a user opens a booster, he needs to pay 0.05 Ether. So, well, next we define some functions. The first one is the mint function, the mint card, this one. So here we can see that we define a function called mint card, which allows to create a NFT or an ERC721 token. So this NFT will represent a card. So this function takes as parameters all properties needed for the creation of the card structure. So the card ID, the club position, etc. Next, we require to mint this card, or to create the NFT, we require the user, the MSD.sender, so the user which is calling this function, to be registered. So you can see here, we require that this MSD.sender equal to this structure, the address stored in this structure. So this user, the caller must be registered first. So the function which registers if a user is given here, which is called register. So in this function we take a hash, and we first require that the user not to be registered. So we require that the address of this user here be to the 0 address. This just means that the user is not registered yet. So after that, we can register the user by writing the user structure. So in the connection data hash, we put this hash here that will allow us later, if when we would like to connect to our wallet, to compare this hash stored in the blockchain with the hash that the user will provide in the front end part. And we put the user address in the caller address in this field here, user address of the user mapping. So after the connection, then the mint card here. So in the mint card, we require that the user has been registered first. Next, we can call the safe mint, which is one of the functions of the Open Zeppelin library that we just import here. So here we imported the Open Zeppelin ERC721 contract here. So we call one of its function here, the SafeMint function, where we put in as parameters the caller and the new card ID. So this new card ID is nothing but this parameters counter that we defined previously. So once the NFT has been created, so by creating this NFT, it means that we have created our card. So we now have a user card. Then we can define all the card properties with the values that we provided here in the function as function parameters. So we come here and just define these properties, the card properties. And also we need to transfer the ownership of the image from to the card. Sorry, we need to transfer the ownership of this card to the card owner here. So the card owners are registered here in this mapping here, card, which map the card ID and the address of the owner. So we need to transfer the card, the NFT here. So this line allows to transfer the owner, to transfer the NFT or the ownership of this card to the user which is calling this function. So next we can transfer the 0.05 Ether to the deposit address. So next function is the open booster function. So a user can create a card either by exchanging their card with another user or by opening a booster. So this function allows to open a booster. So it requires the user to be registered, and it also requires that the user pay some Ether in order to open this booster. Next, we just mint the card, so we create the NFT card here. And next, we set some user properties like the card ID, the card string ID, and we transfer in this line, we transfer the ownership of the card to, the card here. So we transfer the ownership of the card to the minter, this line. And next, we define all the properties of the new created card. And next, we, since opening a booster, should define 5 cards. So we have 5 cards when opening a booster. So we need to select one of these 5 cards. So how to select one of the card among these 5 cards? So to do that, I created here, as you can see, we map. I loop through the number of cards. K here is nothing but the number of cards, so K will be 5 in our case. So I loop through the number of cards and create random numbers. So we need to define, we need to pick up randomly 5 cards. That's why we have this for loop here, which will define 5 cards randomly. And next, here, we call this function define the scarcity. So the scarcity, the define scarcity here is this function that we define here. So it takes as argument a uint and define the scarcity with regard to the value of this card here. So if card is equal 1, then the scarcity is common. If it's equal 2, then the scarcity is rare. 3 is for very rare, 4 is for legend, and 5 is unique. So by calling this function here, since the value here, this value has been picked randomly, then if this value can take one of this value. So this table here, these parameters, this parameter can take one of this value here, 1, 2, 3, 4, 5, and it will define the scarcity of the card. So once we define the scarcity of the card, we can call the .call function with the deposit address to send the 0.05 Ether to this deposit address. So next is to exchange cards, because a user can get a card by exchanging the card with other user card. So the function that do that is this function here, card exchange. So it takes as parameter an address, which is the address of the user with which we would like to exchange the card. And it requires the user, the caller, to have a card. So if a caller doesn't have a card, then he could not exchange a card with other users. So we must be sure that a user which is calling this function already owns a card. And also we require that the other user which will be exchanging this card with the caller owns a card. So if he doesn't have a card, then we cannot call this card exchange here. So once we check this requirement, then we can transfer the caller can transfer his card to this address here, the second user, and he can also transfer this user card to the wallet. Why? So in order for the caller to be able to transfer the second user card to the wallet, this second user first need to allow this caller to transfer the card, his card, to another wallet. So this is possible. This line here is possible only if this second user has approved here, has called this function before. So the approved card transfer. So this function, approved card transfer, does nothing but allow the address that we put in parameter here to transfer the card of the caller from the caller wallet to someone else's wallet. So now we can come here and test our smart contract. So let's test the smart contract. As you can see, I'm using Remix and have some accounts defined by Remix. And first, we need to deploy the smart contract. So, as we saw before, the constructor here, the constructor needs a parameter which is the deposit address. The deposit address, which is the address where all Ether must be signed. So we need to deploy our contract by providing a deposit address. So I will select one of these addresses, the last one, copy it, and deploy with this address. So this address will be the address where all Ethers will be sent. So let's click on deploy. And if we go back here, you can see that the deployment, let's do it like this. Sorry. So as you can see, the contract has been deployed and we have a new contract here. So a new contract instance here. So we can click on this one and see that our contract is working fine. So now let's interact with the decentralized application. First, let's call the open booster function. So to call the open booster function, we need to register first, because this registration step is for security. So we need to secure the user wallet. So let's register first. So to register, we need a string hash. So this string will be provided by information that the user will enter in the front-end login page, for example. But since this is just to simulate, so to simulate the decentralized behavior, application behavior, so one need to select the hash. I would say for this C001 hash, it's a string. So I just select a string and click on register. Perfect. So we can see that the transaction has been confirmed. So next let's open a booster. So to open a booster, we need some parameters. So we need the string, the card ID. So I will say C001. We need the club. I will say club1. The position, avant, the last name, just say card1. The first name, the same, card1. The season, the first season. The strength, we say 2. The endurance 3. The speed 4. The level is level 1. And this initial table. So this initial table is important to define the to generate random numbers. So since we need 5 random numbers for 5 cards, then we need to define it such that it contains 1, 2, 3, 4, and 5. So this is to generate 5 random numbers between 1 and 5. If we wanted to generate 6 random numbers, then we put 6 here. If 7, then 7. So etc. So we just need 5 random numbers. Click here. So next, let's click on transact. And as you can see, we got an error which said not enough ether. This error is due to the fact that we didn't send ether to the deposit address. So we must specify or send 0.05 ether. So you can see here we are in the open booster, and at the end, in the beginning we require the MSG value, the user, to send some ether to the deposit address in order to open the booster. So this not enough ether is nothing but this error here, the error message. So in order to call this function, we need to provide some ethers. To do that, let's come here. Since we need 0.05 ether, then we come here. So we provide 0.05 ether, which is nothing but 50 Fini. So this 50 Fini means 0.005 ether, right? So maybe this one, 0.05 ether. It's nothing but 50 Fini. So now we provide some ether. We can come here and call our function. So transact, and if we go back here, we can see that the transaction has been confirmed, and we can, for example, check which is the owner of the card or the NFT which was created and which has as ID C001. So let's go here, for example. So card owner. So we can check the card owner. Which card? So the card with ID C001, the card owner is this address 0x5b. And if you come here, you can see that the address is, of course, 0x5b. And we can also owner of, so since it's the first card, we just created, or the first NFT created, so we have 0 here. 0 means that first element of a table. So which is the owner of the first element of the table? So this one is nothing but the 0x5b. Perfect, beautiful. So we can also get the scarcity. Remember, we didn't provide the scarcity here. You can see that there is no scarcity here. There is no scarcity, but this scarcity has been generated here by calling the function define scarcity, which takes the parameter, this uint, and compare the value of the uint and define the scarcity accordingly. So we can check the scarcity, get the scarcity string card. So we need the card ID. So the card ID is C001, and if you click on get scarcity, you can see that it's common. Common means that the value generated randomly by this function here, by this part here. So we generate a 5 random numbers and pick up one of these cards. So this card that was picked up has value 1, and the scarcity has been defined as common. So next, we can also check the counter. So we just created one card or one NFT. So if we click counter here, we expect this value to be 1 because from now there exists only one NFT. So count, as you can see, we get, of course, 1 here, this value of 1. So we can also call the check card ID or play with this function here. For example, we can get the season, the card season. Remember, we provided this value, so the season is 1. So we can come here and get season, so which we need to specify the card ID C001 and click and get, of course, 1. So next, one can try to mint a card. So this time we're not going to open the booster, but we're just going to mint a card. So we call this function mint card in order to define a card. So let's change the account. So this is a second user and he would like to get a card. So for that we are going to use the mint card. So the user needs first to register. So we come here for this second user. I just put 2 here. Click on register, and we can see that the transaction has been confirmed here. You can see it here. Next, now that the user has been registered, we can mint. Let's use mint card here to create the user NFT or the user card. So it needs a string. So a string, I will say C002 because this is the second user. For the club, I will say club to the position here. For the last name, I just say card 2 for the first name. For the scarcity, here we need to define the scarcity. So let's say legend. For the season, the first season, for the strength, just put one random values, speed, 4. And for the level, let's say just, or maybe 2, but let's say 1. And now we need to click on transact. But remember, at the end of this function here, we need to transfer some Ether. So mint function, the mint function, this one. So at the end, we need to transfer Ether to the deposit address. So we need to go back here and transfer 50 Fini. And now we can click on transact. Let's go back here. And now let's click on transact. And as you can see, the transaction has been confirmed. Now, if we go back here and, for example, try to get the scarcity. Remember, for the scarcity, we use legend. So if we come here and try the scarcity, we get legend, this one. And for the address, so who is the card owner? So the card owner, let's put GC002. The first one was 0x5B, but this one, the card owner is 0xAB8. So we expect to get 0xAB8 here, 0xAB8. So let's click on it. Perfect. So it's, of course, 0xAB8. Next, we can check the season. So it's this first season, so this number will not change. We get 1 here, of course. So it's C1, and who is the owner of? So this is the second card that has been created. So the second position in the table is nothing but 1. So the owner is nothing but this owner here, 0xAB8. So we expect to get 0xAB8 here. Perfect, 0xAB8. Next, we can also check the counter. So now we have 2 cards, so we expect this value here to be 2. So click on counter and we get 2. Perfect. So next, one can exchange cards. The 2 users that has been created can exchange their cards. So the user C002 and C001 can exchange their cards. So remember, let's select this user here. Copy. Let's go back to the first user. Sorry, yes, to the first user. No, the second user. We copy. So the first user, this one, the 0x5b3, will call the function, this function, the exchange function, this one. The exchange. So yes, so this first user, this one, the first user, this one. So the first user will call the card exchange function. And remember, in this function, this user, the caller, needs to send his card to a second user, this one, but also he needs to transfer the second user card from the second user wallet to his wallet. So this second operation is possible only if the second user has approved or has allowed the first user to realize this the operation, or to send or to transfer his NFT from his wallet to another wallet. So before this first user can be able to call the card exchange, the second user must give him permission. To get the permission, the second user needs to call a proof card transfer first with the address of the first user. So we copy the address of the first user and go to the second user, and this second user needs to call a proof card transfer, this one, the proof card transfer with the address of the first user to allow the first user to transfer his NFT from his address. So click on that. So this address of the first user, we are connected to the second user wallet. So let's allow the first user to transfer the NFT card from the second user. So let's go back and come here. So approve, let's click on approve and look at here if the transaction is complete. So perfect. Now you can see that the transaction has been confirmed. And now we can go back to the first user here, and call the exchange function, this exchange function here, because this first user, this first user has been approved by the second user to send or to transfer his NFT or his card to his wallet. So we can now call a proof card, but before we call a proof card, let's check. So now we are connected. Remember, we are connected to the first user wallet. And let's go back and see that who is the owner, the card owner. So the card owner of 001, the first user, is of course 0x5b, which is this address here, 0x5b. So from now, there is the cards have not been exchanged yet, and the owner of 001 is the owner of the first card, C001, is 0x5b. And now let's transfer or exchange, let's exchange card. So we need the address of the second user. We need to copy it because the first user is going to exchange his card with the data of the second user. So we copy the address of the second user, and now let's click on card exchange. So we passed the second user address and click on card exchange, and here we are. So you can see that the transaction has been confirmed, and let's go and check the ownership of this card. So now we as you can see, the first card as the owner of the first card before the exchange is the 0x5b. But now that the card has been exchanged, we can check who is now the owner of this card. So let's click on card owner. Look here, now it's 0x5b, and when we click on card owner, so card owners, not this field. Let's go here, because this card owners has been defined in the smart contract, and I didn't change this information here. So we can go back and look the same function but defined in here. So owner of 1. It is exactly the same function, but this one has been defined in the OpenZipLink contract. So, but in this contract, I didn't change the ownership of the card when calling this function. So we can check it directly here. So who is the owner? Before the exchange, the owner of this card, the second card, is 0xab8. But now, if we click again, because the card has been exchanged, this owner should change. So let's click on owner of. Here we are. So you can see that it changes. And if we look at the owner of the first card and the address, it changes. So click on it and it changes. So this shows that the two users have exchanged their card. And remember, this address 0x5b3 created the first card. So the card at 0 position in the table, 0 index. So 0x5b3 created the card at 0 position. So 0x5b3 must be at 0 position. So here 0, see, 0 who created this card, but the first user, 0x5b3. But now at 0 position, it's not 0x5b3. It's not this account, but the second one, 0ab8. 0AB8. So go back and see that it's 0AB8. Why? Because the cards have been exchanged. So I stop here, and as you can see, everything is working just fine. Users can create a card, can open a booster, and they can also transfer or exchange the card. So thank you for